Hello everyone, welcome back to our channel Code with AKJ. Today is day 46 of solving GeeksforGeeks problem of the day, and today's problem is count linked list nodes. So the question says here, given a single linked list, the task is to find the length of the linked list, where length is defined as the number of nodes present in the linked list. So today's problem is pretty straightforward. We are given a single linked list, and the task is to find its length, that is, count the number of nodes in the given linked list. So given two examples here. The linked list 1, 2, 3, 4, 5, it contains 5 nodes, so we need to return 5 value here. And given second example, the linked list contains 7 nodes, so we need to return the count of nodes, which is 7 here. And they are expecting us to finish it in O of n time complexity, and space complexity should be O of 1. Now let's discuss the approach first here. So let me write the linked list here, which is 1, 2, 3, 4, 5. The plan is pretty simple. As we iterate over this linked list, we'll take the help of a counter variable c, which would be initially 0. And as we move over these nodes till we reach the end of the linked list, we'll try to increment our count variable. And in this way, we'll able to count the number of nodes present in this given linked list. So let's quickly try run this. So initially we would at our head pointer, and we'll start our counter from 0 to 1. And again, until or unless this current pointer is pointing to null, we'll move this current pointer to the next node. So it moves from 1 to 2. Again, we'll increment our counter to 2. Again, it will move from 2 to 3. We'll increment our counter from 2 to 3. Again, it moves from 3 to 4. We'll increment our counter to 4. And again, we'll move from 4 to 5, and we'll increment our counter to 5. And since we reach at a null, we'll stop our iteration and we'll return our count variable here. So the approach was pretty simple, and the time complexity here would be O of n, as we are iterating over the linked list just for once, and space complexity is O of 1, as we are not using any external data structure here. So let's move on to the code here. So let's start with our base case. If head is null, we'll return 0, as there will be no nodes present in the null linked list. And let's take a counter variable which would be initially 0. We'll take a temp node pointer which would point at head, and the definition of this temp would be struct node star, and we'll start iterating over this linked list until or unless it reaches null. And we'll increment our counter variable, and we'll move this temp variable to next node. And finally, we'll return our count variable which contains the number of nodes present in this given linked list. So let's try to compile this. So let's submit. As you can see, this problem got accepted successfully. So here the time complexity is O of n and space complexity is O of 1, as our expected time complexity and space complexity. So since the brute force approach already gave us an optimal complexity of O of n and space complexity as O of 1, there isn't much more we can do in terms of improving the efficiency. However, one small thing we can optimize is to use the memory usage, which we can optimize it, especially for handling very large lists. So one possible improvement could be recursive counting, but it would add a little more memory overhead due to the recursive functions. So let's discuss that briefly. So in the recursive approach, we can count the nodes by breaking down the problem into sub problems, and for each node we count it, then recursively move to the next node and keep adding it to the count. So let's try to code that approach as well. So same here, if head is null, we'll return 0, and if not, we'll recursively call the same function by adding 1 to the count variable. We'll send the next part of linked list through head next to recursively call this function again and again, and in the same way we'll add one value to increment our count variable. So let's try to compile this. So let's submit. As you can see, this problem got accepted as well. So that's all for today. We have walked through both the iterative and recursive solutions for counting the number of nodes in a single linked list. For this problem, the iterative approach is considered the most efficient in terms of both time and space. I hope this video helped you get a better understanding of linked list traversal. Let me know in the comments which approach you prefer and why. So if you enjoyed this explanation, please hit the like button and subscribe to the channel for more daily coding problem solutions. Also, don't forget to hit that bell icon so you get notified whenever I post a new video. Thanks for watching, and I'll see you in the next one.